let's take a look at this example. Bill is adding 358 plus 127 mentally. You ask him to explain his methods verbally and then write equations that go with his statement. So he says, I added 360 and 130 and got 490. Then, since I added, so 2 plus 3 is 5 too much. I needed to take it away, so I get 485. So instead of using 358 and 127, he used 360 and 130. But then because he like added 2 and added 3, that means that he added 5 too much. So he needed to take that away. And so then the 490 he got, take away 5 to be 485. And then he wrote 358 plus 127 equals 360 plus 130 equals 490 minus 5 equals 485. So that just reflects his process that he did. So the first question just asks, is his method valid? Yes, it absolutely is, right? So what he says is perfectly fine to do. This is a great mental math strategy, is just like go to something that it's close to, right? 358 is close to 360. 127 is close to 130. 360 and 130, that's a lot easier to add in your head than 358 and 127. But since we like kind of bumped both of those up, we bumped the first one up by 2 and we bumped the second one up by 3, that means that we actually added 5 more than we should have. So we need to subtract that off in the end. So you can see that here. And then, is his big long equation valid? No. And so that's where we have an issue with what I call equal sign misuse. So with the equal sign misuse, this is something that as a student, we didn't necessarily get corrected for this because the teacher could tell that we were doing the right process. We can tell that Bill's doing the right thing. Okay, they changed this and said, well, that's really like doing 360 plus 130. And then that gave him 490. And then he realized that he added 5 too much. So he subtracted that off and got 485. We can see the process and the process is right, but the equation is not, right? So if you look at this, like 358 plus 127, right? We know that that equals 485, right? But not all of these equal signs that we're seeing here are true. So like if you look at that first set of expressions with an equal sign, you've got this expression equals this. That's not true, right? 358 plus 127 does not equal 360 plus 130, right? He essentially kind of rounded up, right? And like those aren't equal. And then if you look at the next equal sign that we have, so this is the next equal sign, look at those two expressions. That's not true either, right? 360 plus 130 does not equal 490 minus 5, right? Sorry, that's supposed to be a 9. 360 plus 130 equals 490, and then the next step was to subtract 5, but those are not equal to each other, right? If a student sees this written on the board, especially if they look down for a minute and then look back up, and they're going to look at that and be like, what do you mean? 360 plus 130 does not equal 490 minus 5. That's not equal, right? So this doesn't work to have this big string of equal signs that aren't equal like this. So the equal sign means that the two things are exactly the same amount. And it does not mean, and then I did this, right? Which is kind of how Bill's using it, and we'll see some students use it. So if you ever see me write equal sign misuse on your paper, this is what I'm talking about, is where like you've got some issue where like this doesn't equal this, or this doesn't equal this somewhere along the way. So how do you fix that? There's several ways you can fix that. So one method would just be to write separate equations, right? So like you would have one line where we said, okay, we did, instead of the 358 and the 127, we did 360 plus 130, and then we got 490. But then instead of like keep going and like writing +5 or -5, then we would go to a separate line or a separate equation. Say, okay, now that I got 490, now I realize that's 5 more than it was supposed to be. Now let me subtract 5 and see what that gives me. So splitting up that equation into several equations is a great way to go. You can do it where you have like a big run-on equation. You just have to be really careful that everything is equivalent. So if you wanted to do that for this problem, we would technically, so we would not want to say that 358 plus 127 equals 360 plus 130, because it doesn't, right? We could say, well, we could use 360, but then that's technically 2 more than we needed, so we'd have to subtract 2. We could use 130, but since that's 3 more than 127, we'd have to subtract that off. So we could rewrite it that way, right, where we actually write all the numbers there that this is equal to. Then we could use the commutative property. So that means a lot of times when we do a mental math strategy, we're not aware of the properties that we're actually using. That strategy that we did is actually using the commutative property, because it's saying, well, I don't want to do 360 minus 2 and 130 minus 3. I want to put the 360 and the 130 together because that's easier to do in my head. So let's use the commutative property and move those things around, right? And put the 2 and the 3 together, say, well, if this one was 2 more than it was supposed to be, and this one was 3 more than it was supposed to be, that's 5 more, right? So that's putting the 2 and 3 together. So using the commutative property, and then it's also using the associative property, saying, hey, since this is all addition, or I could rewrite it as addition of negatives with the minus signs, then we can associate those together. So that's another way that you could write that correctly without having any equal sign misuse.